Download this code from codegive.com, link in the description below. OWASP Top 10, 2017. A deep dive into XML external entities, XXE. This tutorial provides a comprehensive understanding of XML external entities, XXE, vulnerabilities, a significant security risk that ranked 4 in the OWASP Top 10 2017. We'll explore what XXE is, why it's dangerous, how to identify and exploit it, and, most importantly, how to prevent it. While XXE vulnerabilities are still prevalent today, this tutorial focuses on the 2017 classification to understand its historical context within the OWASP Top 10. What is XML and why do we use it? XML, extensible markup language, is a text-based markup language designed for encoding documents in a format that is both human-readable and machine-readable. It's widely used for data exchange between applications, configuration files, and persistent data storage. XML uses tags to define elements and attributes to describe them. A simple example. What are XML external entities, XXE? XML external entities, XXE, are a feature in XML that allows you to define a placeholder, an entity, whose value is not within the XML document itself, but rather points to an external resource. This external resource can be a file on the local file system, a URL on the internet, or even a system command. Think of it as an include statement within your XML. Key components involved asterisk. XML parser the software component responsible for reading and processing the XML document. Many programming languages have built-in XML parsers or libraries. XML entity a named storage unit in an XML document. Entities can be used to represent common text or data. Two main types of entities are important for XXE. Internal entities defined within the DTD of the XML document. Example, entity copyright 2023. External entities defined to point to an external resource. This is where the vulnerability lies. Example, entity XXE system file : /etc/password. DTD, document type definition, an optional part of an XML document that defines the structure, elements, and attributes that are allowed in the document. It can also declare entities. DTDs are often embedded within the XML document or referenced externally. DTDs are more relevant to XXE vulnerabilities in older systems. Modern XML processing often relies on XML schema, XSD, for validation, but XXE can still occur even without a DTD. XML schema, XSD, a more robust alternative to DTDs. XSDs define the structure, data types, and constraints of an XML document. How XXE works: the attack vector. The vulnerability arises when an XML parser processes an XML document containing an external entity definition and resolves, loads and processes, the external resource pointed to by the entity. If the attacker can control the external entity definition, they can point it to a sensitive file or URL, and the parser will unknowingly retrieve and return the contents to the attacker. Example scenario *. Imagine a web application that processes XML files to store and retrieve user data. Let's say the application's code looks something like this, using Python and the xml.itree.elementtree library. In this vulnerable code, if the XML_data is supplied by a user, example uploaded via a file upload, sent in a POST request, an attacker can inject a malicious XML payload. The malicious XML payload *. Explanation of the payload *. 1. XML version equals 1.0, standard XML declaration. 2. Doc type foo. Defines a document type definition, DTD. The DTD is where the external entity is declared. Foo is the root element of the XML document. 3. Element foo any, defines the foo element as allowing any content. This is a loose definition and allows the XXE exploit to work. 4. Entity XXE system file : etc/password, this is the crucial part. It defines an external entity named XXE. The system keyword indicates that the entity's value is loaded from a URI. File // etc/password is a URI that points to the /etc/password file on the server's file system, assuming a Linux-based server. 5. Foo and XXE, /foo, this uses the defined entity. The and XXE is a reference to the entity. When the XML parser processes this, it will replace and XXE with the contents of /etc/password. The outcome *. When the process_XML function receives this malicious XML payload, the XML parser will 1. Parse the XML document. 2. Encounter the DTD and process the entity declaration. 3. The and XXE entity will be expanded. 4. The contents of /etc/password will be read. 5. The process_XML function will, likely, return a string representation of the parsed XML document, now containing the contents of /etc/password within the foo element. This content is printed in the example code. The attacker has successfully extracted sensitive information from the server. Why is XXE dangerous? XXE vulnerabilities can lead to a range of serious security breaches. Sensitive data disclosure *. As demonstrated, attackers can read arbitrary files on the server's file system, potentially exposing passwords, configuration files, source code, database credentials, and other sensitive data. Denial of service. An attacker can point the external entity to a large file or an infinite loop, causing the server to consume excessive resources and potentially crash. Server-side request forgery, SSRF. An attacker can use the XML parser to make requests to internal services or external websites that are not normally accessible from the outside world. This can be used to scan internal networks, bypass firewalls, and exploit other vulnerabilities. Remote code execution, RCE. In some cases, and with certain XML processors that support features like XSLT, extensible style sheet language transformations, XXE can be chained with other vulnerabilities to achieve remote code execution, allowing the attacker to run arbitrary commands on the server. Identifying XXE vulnerabilities *. Several approaches can be used to identify XXE vulnerabilities. Code review *. Manually examine the source code of the application to identify places where XML is being parsed and processed. Look for usage of XML parsing libraries and check how external entities are handled. Pay special attention to user-controlled input that influences XML processing. Black box testing *. This involves sending various XML payloads to the application and observing the response. Try injecting different external entity definitions, pointing to files that should be accessible, example /etc/password on Linux, see /boot.ini on Windows, if you know the server operating system, and files that should not be accessible. Observe the error messages and responses to see if they reveal file contents or other sensitive information. Gray box testing *. This involves having some knowledge of the application's internal workings, example the XML parsing library used, while performing black box testing. This allows for more targeted and effective testing. Static analysis security testing, SAST, tools. SAST tools can automatically scan source code for potential XXE vulnerabilities. Dynamic analysis security testing, DAST, tools. DAST tools can test running applications for XXE vulnerabilities by injecting malicious XML payloads. Exploiting XXE vulnerabilities. Exploiting XXE vulnerabilities involves crafting malicious XML payloads to achieve a desired outcome, such as reading files, performing SSRF, or triggering a denial of service. 1. Reading local files, file disclosure. As demonstrated in the earlier example, this is the most common type of XXE exploitation. The attacker injects an XML payload that defines an external entity pointing to a file on the server's file system. Example *. This payload attempts to read the /etc/shadow file, which contains password hashes, on Linux systems. Note that reading /etc/shadow often requires root privileges, so this may not always be successful. 2. Server-side request forgery, SSRF. The attacker crafts an XML payload that defines an external entity pointing to an internal service or an external website. Example *. This payload attempts to make an HTTP request to http://internal.example.com/admin. If the server is vulnerable to XXE, it will make the request on behalf of the attacker. This is particularly dangerous if internal.example.com is a protected internal service or a resource behind a firewall. The attacker can then potentially access or manipulate internal resources that are not directly exposed to the Internet. 3. Denial of service, DOS. The attacker crafts an XML payload that defines an external entity that causes the XML parser to consume excessive resources. A common technique is to use recursive entity definitions, also known as a billion laughs attack. Example *. This payload defines a series of entities that recursively expand, resulting in a huge string in memory. When the XML parser tries to expand the and LOL9 entity, it will consume a significant amount of memory and CPU, potentially leading to a denial of service. Preventing XXE vulnerabilities *. The most effective way to prevent XXE vulnerabilities is to disable the processing of external entities and DTDs in the XML parser. Here are specific recommendations for common programming languages and libraries. Java disable DTD processing use the javax.xml.parsers.sax parser factory or javax.xml.parsers.document builder factory to disable DTD processing. *.net, c. Disable DTD processing and external entities. Use the XML reader settings class to configure the XML reader. Python use diffused XML instead of xml.itree.elementtree. The diffused XML library is a safer alternative to the standard xml.itree.elementtree library because it disables external entity processing by default. If you must use xml.itree.elementtree, you can modify the XML parser behavior. This approach uses a custom parser that forbids entity resolution, preventing the XXE attack. *php*. Disable external entity loading and DTD validation. Use the libxml_disable_entity_loader function and set libxml_load to false. General recommendations. Input validation sanitize and validate all XML input to ensure that it conforms to the expected schema and does not contain malicious entity definitions. This is a defense in-depth measure and should be used in conjunction with disabling external entities. Consider whitelisting allowed elements and attributes. Least privilege run the application with the minimum necessary privileges to access the resources it needs. This limits the damage an attacker can cause if they are able to exploit an XXE vulnerability. Regular security audits conduct regular security audits to identify and address potential XXE vulnerabilities. Use both automated tools and manual code review. Keep libraries up to date. Regularly update the XML parsing libraries and other dependencies to ensure that you have the latest security patches. Consider using a different data format. If XML is not strictly necessary, consider using a safer data format like JSON, which is not vulnerable to XXE. Web Application Firewall, WAF can be configured to detect and block malicious XML payloads that attempt to exploit XXE vulnerabilities. Beyond the code, security practices. Security awareness training. Educate developers and security personnel about the risks of XXE vulnerabilities and how to prevent them. Secure development lifecycle. SDL incorporate security considerations into every stage of the software development lifecycle, from design to deployment. Vulnerability management. Implement a vulnerability management program to identify, track, and remediate vulnerabilities in a timely manner. Important considerations. Modern XML parsers. Many modern XML parsers disable external entity processing by default. However, it's crucial to explicitly verify this configuration and not rely on default settings. The defaults might change, or someone might have accidentally re-enabled external entities. *X-include *X-include is a standard for merging XML documents. While not technically XXE, it can be exploited in similar ways to perform file inclusion and SSRF. Disable X-include processing if it's not required. SOAP, Simple Object Access Protocol. SOAP, a protocol for exchanging structured information in web services, relies heavily on XML. SOAP endpoints are common targets for XXE attacks. Conclusion. XML external entities, XXE, vulnerabilities pose a significant threat to web applications. By understanding the principles of XXE, how to identify and exploit it, and, most importantly, how to prevent it, you can significantly reduce your risk of falling victim to this type of attack. Remember that the most effective mitigation strategy is to disable external entity processing at the XML parser level. Defense in-depth strategies like input validation and regular security audits further enhance your application's security posture. While XXE was 4 in the OWASP Top 10 2017, its potential for exploitation and impact remains relevant in today's security landscape, so understanding and mitigating this vulnerability is still critical.